Welcome to the third and final part of my compilation. This part dwells in detail with the concept that we have evolved or that we propose to integrate new innovative technologies to enhance IBMS or UBMS. So, what is partial integration and how is it achieved? First, we come to the first point is creation of bridge information model. Data is available in UBMS relating to the number of spans and the geometry within these spans. Based on the data relating to the configuration of the element, we can create a schematic 3D model of the bridge. This is a geometrical model and it is not a digital twin. Various photographs of the bridge are then attached to the bridge information model. For elements which show distress, continuous photos or overlap are used to create 3D model which is only for that distress element. This 3D model is created based on drone captured videos or photographs. This model created is for one distress element with detailed of location of distress in the element. Since it relates to the location of distress in the element, we have termed it as LODE 3D model. Creation of such LODE 3D model using real-time photograph ensured that correct and precise location of the distress is captured. These models are small in size and for individual members. These models can be stored with the element number being used as a file name followed by the year of inspection. 3D model for various distress elements are stored in UBMS database as per the year of inspection. Two important usages emerge from this creation of bridge information model. Firstly, the overall distress progression for the whole structure can be evaluated. Based on the model, the successive inspection, a time series progression of distress for that element can be generated. Second important use of load model is in evaluation of quantities for various items of repair interventions. Load model is used for further analysis of distress in the bridge and the impact of such distress for the performance of the bridge. This evaluation is critical for decision making. Capacity evaluation essential can also be integrated once we have the design data. This is unavailable in an Indian scenario. The proposed protocol for evaluation has essentially three steps. First step is to determine the element which show worst or severe distress. The second step is to install structural health monitoring and monitor such identified critical element for 72 hours under normal live load. The third step is evaluation of deterioration process to identify the cause of deterioration based on collected information. Most of the processes of deterioration can be very well initiated and progression path can be easily captured. The analytics provide additional data related to the distress and over time to enable authentication. Based on the result of the first cycle, the periodicity of all further monitoring can be done. The concept involves adaptation of the principles used in development of bridge information model or the BRIM and evolve a functionality within UBMS, Unified Bridge Management System, to provide geospatial information about various distress elements of the bridge. We then would apply photogrammetric tools and create a 3D model which will indicate the location of distress element. Since this defines the location of distress element, we call this model as the load model, LODE. L for location, O of D for distress and E for element, LODE model. We will have one load model for one distress element captured on a particular time frame. More load models attached to one single bridge for that time frame indicates the severe distress in the bridge. Similar load models can be uploaded to the bridge on progressive inspections. Study of load will provide us with and help us in understanding the criticality of the element with respect to the stability of the bridge. We then would deploy a 72-hour structural health monitoring system on all such elements for live monitoring, performance monitoring for actual live load. This enables us to understand the performance of the element, and based on the structural health monitoring, we can also confirm the cause of deterioration. Progressive study of such SHM structural health monitoring output over a period of time can result in a better understanding of the progression of deterioration in that element. Such a study will lead us to create a realistic deterioration model based on performance. This deterioration model is an enhanced deterioration model. Remember, in the first IBMS version, we had a deterioration model created on symptoms. The second version, that is the Unified Bridge Management System or UBMS, had a deterioration model created on the cause of distress. This third version is trying to integrate the performance, integrate the performance monitoring, structural health monitoring systems to create a deterioration model which is more realistic because it is based on performance of individual distress element. Thank you for having a patient hearing. Thank you.